We are, of course, on page 836, but you're going to need to have page 835 table done because the calculations you're being asked to answer on page 836 need those totals. So if you haven't watched the video yet, thank you for the views, but here it is right now for you as well. Of those surveyed, well, first of all, I'm getting into this one. Use the two-way frequency table to answer each question and describe how to use the rows and columns to determine an answer. So 3A, maybe pause the video here, by the way. Give yourself a gap there and then some gaps here and gaps here because we're going to need to fill in some of the missing pieces. So pause and write, and then I'm going to resume here in a second, and we're going to answer 3A. Thank you for pausing, writing it down. Let's go. Of those surveyed, there are a certain number of people who are left-handed and do not play sports. That is this one. They are left-handed and they do not play sports. So there are 8 people in that category. And the way to figure that out is to use the row for left and the column for does not play to know that when that row and that column meet, they're meeting at cell 8. How many of those surveyed are right-handed or play team sports? And I'm going to use my yellow highlighter for this one. Because of the word or, we have to be a little bit more concerned with something. First of all, we're going to tally up the total right-handed and the play sports teams in their rows and columns. So right-handed would be all 33 people in the class that are right-handed. And then or play team sports is the column for team sports. There are 39 people in this class that play team sports. However, there's an issue. We're going to count the 23 people in that pile twice. Probably the easiest way is to do 33 plus 39, take away 23. So right-handed, play team sports, take away the overlap. So that'd be 33 plus 39, take away 23. Hey Siri, what's 33 plus 39, take away 23?
33 plus 39 minus 23 is 49.
The other way to use the table though, so that, by the way, there are 49 people in the class who are right-handed or they play team sports. We just got to make sure we take away the combination of where they are right-handed and play team sports because they're getting counted twice. We could also ignore the totals and just add up the numbers that are highlighted in the rows and columns. Hey Siri, what's 13 plus 6 plus 23 plus 4 plus 3?
13 plus 6 plus 23 plus 4 plus 3 is 49.
That's the other way to do that. You just count them, if they're highlighted, count them one time, add them up. So once again, we get 49 from 13 plus 6 plus 23 plus 4 plus 3. That's the other way of just adding up the ones that are yellow. Ooh, good use for the highlight right now. How many of those surveyed played any kind of sport? And the easiest way to do that is to count up either both of these columns, because individual and team, or I'll show you a trick in a second. Any kind of sport is the sum of the individual and team columns, sum them up. So 10 plus 39, which equals 49. Coincidental that those are the same. Not intentionally going to be the same always, but just coincidental. The thing is, the other way is to subtract do not play from total. So if the total is 63, if we take away the do not play from the total, we're left with every other option of actually playing. Hey Siri, what's 63 minus 14?
63 minus 14 is 49.
Yo, there's a couple of ways you can mathematically and gymnastically flip your way around the answers here. So Campbell decides that the figures in the studies are correct because the study is that the participating in sports is related to handedness. Good science for a project. In a sport, more are left-handed than are mixed people. Do you agree with Campbell? Once more time. Campbell claims that the figures in the studies are correct because more right-handed people participated in a sport than left-handed and mixed-handed people. Do you agree with Campbell? Explain your reasoning. Well, first of all, no. No. Campbell decided or needed to calculate the percentage for each category to be able to compare across handedness. This is just a frequency count contingency table. How many people? At no point did any of the students or Mr. Harris or Campbell decide to figure out the percentages. To do that, you would do 3 divided by 63, 13 divided by 63, 8 divided by 63, 24 divided by 63. In fact, the entire table, all of the numbers, even the total, is divided by 63, the total, and you calculate your percentage that way. Once we have percentages, then we can start using on a more level playing field, a little more level ground, sports metaphor, I know, to make a comparison between handedness and sports participation. But just based upon count and frequency, this is not sufficient. It's good for discussion. It's good to point at specifically, but to really start making some adjustments and some broad sweeping statements, we should take out the total and talk about percentage. What is the percentage of students who are left-handed and do not play sports? That would be a little bit more leveled. Because there are 3 types of people who participated in the survey, Mr. Harris's students cannot claim that the study's figures are correct simply by looking at the frequencies. Instead, they must look at relative frequencies, aka percentages. A relative frequency is the ratio of occurrences within a category to the total number of occurrences. To determine the ratio of each category, determine the part to whole for the category. Literally divide everything by the total. And in a 2-way relative frequency table, it displays the relative frequencies, percentages, for the 2 categories of the data. Some parting questions. Did you use an intersection or a union to calculate these results? I think you might want to remember this and is intersection and this or is union. And when you do a union calculation, something's getting double counted. Why isn't your answer to part B just straight up 33 plus 39? 33 plus 39 is 72, easy enough to calculate. Why did we have to take away the 23? Do you know? I know I've said it, but have you processed that? Why do you have to take off the 23? What information does a relative frequency table provide that a frequency table doesn't provide? You know, if you have a class size of 63 and you want to broadly compare it to the entire high school, you're going to find way more than 24 people who are left-handed. You're going to find way more than 33 people who are right-handed. You're going to find way more than 6 people who are ambidextrous, mixed-handed. It's not really fair to compare then based upon the count, straight up just counting, unless you use percentages. So percentages, relative frequency uses percentages. Using percentages, we're able to more closely compare a small set of data or a sample size to a larger set of data. Thank you for watching page 835. 836 is next. We're going to be using this frequency table, so have page 835 handy as we answer page 837. Like, comment, and subscribe, and I'll see you in the next episode.